Okay, so in this class, we'll do this test portion, chapter 10, chapter 6, class 10, triangles. We'll go to exercise 6.2, question B2 and 3. After this, there's a test. Okay, so let me read the question there, page 134. Question number 2, B2. To be specific, B2. Let me read the question. E and F are points on the sides PQ and PR respectively of triangle PQR. So let's draw that. So here, P, Q, R is there. Okay. E and F are, E is on PQ. So this point E is on PQ and this point F is on PR. So if you join them, that's the line. For each of the following, state whether EF is parallel to QR. So let's take the first one, subheading 1. Here, values given are PE is 3.9 centimeter. Then EQ is 3 centimeter. PF is equal to 3.6 centimeter. And FR is equal to 2.4 centimeter, the first one. So here, let's take here in this triangle PQR that is given to us. Okay, we know this one. If this line joining 2 points on the 2 sides of triangle, okay, if that line cuts like that, and if this ratio PE, how this line cut these 2 sides, this one and this part, divided PE by EQ is equal to, then here, PF by FR, then only this line here, EF will be parallel to QR. We did this in the previous one class, this theorem, and this theorem is called since using, we have to write like this, converse of basic proportionality theorem. So basic proportionality theorem says that if a line is parallel to one side of the triangle, then that line will cut the 2 sides it is touching in the same ratio, means it will be like this. But the converse is, if a line divides 2 sides and the ratio here PE by EQ and PF by FR are equal, then the line will be parallel. So we're using the converse. Okay, so let us take out the left hand side. So left hand side is equal to this one, PE by EQ. Left hand side is equal to PE by EQ. Left hand side is equal to PE by EQ, as you can see here. So PE is given as 3.9, so we write that one, 3.9 centimeter by EQ is given as 3, so let's write that. Then centimeter cancel, and let us remove the decimal by 10 to remove this one place. Using this 0, then it will become 39, and 3 tens are 30, so that we don't have decimals. This is one good way of doing it. And let us cancel this number to as low as possible. 3 tens are 30, 3 1, 3 2, 2 5, and 2 6 are 12. So we're going to get equal to 6. Cancel as much as possible till you can't cancel anymore. And that form is called the standard form. Okay, 6 by 5. So reduce it to the lowest form like that till you can cancel it. Then right hand side also you do the same. PF by FR. So we'll do slow this one, and the next one we can do faster. PF by FR. And here you can see 3.6 PF. So write that one, 3.6 centimeter by FR here, 2.4 centimeter. So these two cancel. Then you multiply by 10 again to remove this decimal, you see. Decimal move right because of 1 0, 36. Move right because of this 0, 24. Then cancel. 6 4s are 24, 6 6 are 36. 2, 2 and 2, 3. So this is here. 3 is divided by 2. When you cancel to the lowest possible, no more cancellation possible. So we see after that only you can compare. That's why we're doing that. Only when you cancel it to the lowest number possible, you can compare whether they are equal or not. So now we see left hand side is 6 by 5 and right hand side is 3 by 2. So they are not equal. So because they are not equal, EF cannot be parallel to QR in this case. So it's not parallel to QR. So this is the answer is no, right? Now let us go to the next one, 2. 2 there, look into your text. PE is 4. So here, this time it is 4 centimeter. QE, okay, QE is given as 4.5 centimeter. PF is given as 8 centimeter. PF, and then RF is given as 9 centimeter. So these are the values given. So now this same we will write up to here, then we'll go there. Okay, right up to here. Pause the video and write and come and replay it. Now next, left hand side, therefore, as you can see, is PE by EQ. So here PE is 4 centimeter by EQ or QE, same thing. EQ or you say QE also is the same line segment. So QE is 4.5 centimeter. So we can cancel out the unit. Multiply by 10 to remove this decimal, because we want it to be in the form of no decimal. 4 tens are 40 and there's a decimal removed because of this 0. Then 5 eights are 40, 5 nines are 45. So 8 by 9. After that we cannot cancel, like that we reduce. Then the right hand side likewise will be PF by FR. PF by FR. Now PF is here 8 and 9. So 8 centimeter by 9 centimeter. So can't cancel that. So now this time we see left hand side is 8 by 9. Right hand side is also 8 by 9. They are equal. So EF will be parallel to QR. Yes, this one. One more is there, 3. Number 3, the PQ. This time it's a different set of values, so let's write it down. PQ is equal to 1.28 centimeter. PR is equal to 2.56 centimeter. PE is equal to 0.18 centimeter. And PF is equal to 0.36 centimeter. This much given to us. So with this, we write here same thing in triangle this one. If these two are equal, then they will be only parallel. Up to here, you pause the video and write it. Come and rejoin. Let's take out the left hand side here. Left hand side is PE by EQ. So let us write that. PE by EQ, right? So here PE is given. So you can write that quantity 0.18 centimeter, as you can see here. But EQ, EQ is not directly given, so you can just write EQ here can be written as in this format: PQ minus EPE. See here, PQ minus PE is EQ. So EQ has to be written in terms of PQ because they gave you only PQ. So you can do like that. Okay. So that will be equal to here 0.18 centimeter divided by PQ here 1.28 minus PE 0.18. Sorry, 0.18. And centimeter here can come out of the bracket, so you can cancel this. 0.18 divided by 1.28 minus 0.18. 0, 1, and then 1 minus 0, 1. So it will be 1.10. So to remove this decimal where it's 2 place, so I put 2 zeros now, 100 up and down. So we don't have decimal, so we can cancel and compare, right? So here this 2 0 means 1 2 place shift here. Decimal means no more decimal now. This one also 1 2. So now we can cancel. 2 5s are 10. 2 9s are 18. So 9 by 5. Let us likewise do the right hand side. Right hand side here is PF by FR. PF by FR. Now here PF is there, so we can just write that down. 0.36 centimeter. And FR here can be written as PR minus PF. PR minus PF, because only PR is given this time. So here that will be equal to 0.36 centimeter by PR 2.56 minus PF 0.36, and common centimeter can come out. This to cancel means you're going to get here equal to 0.36 divided by 2.56 minus 0.36. 0, 2, and here 2 plus 2.20, so 2.20 or 2.2. 2 decimal places, both numerator and this one. So 100 by 100 means it will get removed completely. So this one 36 divided by this 2 0 means 1 2 shift to the right. So here 4 5s are 20, 4 9s are 36, 9 by 5. So we see left hand side is equal to right hand side. As you can see, left hand side is 9 by 5, right hand side also 9 by 5. So that line EF is parallel to QR. In the third case also is yes. So these are the 3 sub questions under question number 2. 1, 2, 3. B2. Now one more question before we end this class. B3. Let me read the question for us. In the figure 6.22, this LN parallel CB, LN parallel to CD. So let's just draw the figure first. There in the towards the upper part, there is a figure like this, 6.22. So here, this line comes like this. This line comes parallel to this. A, B, C, D, N, L, and M. Draw that, okay? Then write down what is given to us. Given to us is clearly in the figure, okay, in the figure, there question number 3, LN is parallel to CB, and not only that, LN is parallel to CB and CD. That is given. We have to prove something. So let's write that. To prove means that's our part. With this information, we have to prove that AM by AB is equal to AN by AD. AN by AD. Okay. So proof means the answer for this. Proof PROOF is the answer. Our proof. Okay. So here, let us take this triangle here. So in triangle ABC, this one here, LM is parallel to CB, because it is given in the question like that. You can see here LM parallel to CB. this line parallel to CB. So we know that we can now apply basic proportionality theorem. So here we can write, therefore, basic proportionality theorem, if a line is parallel to one side of the triangle, then that line will divide the remaining two sides in the equal ratio, means like this. Don't write this one now. AM by MB is equal to AL by LC, right? But there is a corollary. Corollary means another theorem derived from the main theorem. This one is the main theorem. So AM by MB, like that also, we can change it to AM by the full line AB, so that we match this question format here, see. So if you write AM by AB, AM corresponds to AN, so we have to write here, AL, that is correct, AL. AM by AB full line means AL by, instead of LC, AC, that is also allowed. And this is called corollary to basic proportionality theorem. Means corollary means this theorem is taken out of the main theorem. So if it's a corollary, then you can just write the main theorem as the reason using basic proportionality theorem. So you can just use the same theorem as the reason. Okay, let us keep this one as equation 1. Similarly means in the same way, in triangle ADC, the lower one, ADC, since we know here LN parallel to CD, here also this line parallel to CD, so we can apply the same one. AN by this full line AD will be equal to AL by full line AC. No need to give reason because we put similarly. Okay, now continue doing this. See here now, these two are same. So in place of this, you can put this one, AN by AD. In place of this, now you put AM by AB, since using equation number 1. So now, hence proved. That's your answer. See, AM by AB here is equal to AN by AD. So that's how you do. So go and give the test. The test for this one is exactly the textbook question only. You have to do it on your tuition copy and submit the same one for correction. Okay.